How's it going, everybody? Thanks for coming out. I'm going to give you a talk today about some cool stuff, I hope. But I got a question first. Is anybody tired? No. That guy is. Not a plant. I got good news for you, man. I'm going to give you a lot of rest. Say that into the mic, please. So I'm Chris DaMour. I'm an engineer on the commerce team here. I joined bodybuilding in March of 2014. And my first conversation with my boss kind of went like this. He said, hey, we need mobile store apps. And I said, I got a phone yesterday. I literally got a phone, a smartphone, my first one the day before I started at bodybuilding. And I was really into it. I was like, this is cool. We should build mobile apps. Turns out they didn't want me to build the app. They wanted me to build the API. And the reason that was because they wanted to build a consistent user experience across all their different platforms. They have MDOT, they have full site, they had two different mobile apps they were going to build, iOS and Android. And they wanted the same features, performance, maintainability, and especially the business control, because we have a lot of really awesome business controls in place at bodybuilding where the business can do things. Flash sales, promotions, targeted advertisements. They needed all that on all the platforms. So roughly said, we need an API. I said, great. It took about a year, but we made it. We got them. They're out there. If you check them out, I think they're really fast. I think they're really neat. And what happened is artifacts started coming out of that year-long project, because if you do anything for a year, you're going to have something worthwhile, right? And one of the biggest artifacts was the knowledge we obtained from this. And so this presentation is to try to give you some ideas and some of the ideas and things that we learned by doing this project. And the first thing I want to start off with, and if this is the thing that you can walk away from here and remember, so please remember this. REST APIs, there's really no such thing. If you ever say REST API, and I'm sorry to everybody who said it before, that's an atrocity to the level of parking over the line in the parking lot. When someone comes to you and says, I'm going to build a REST API, I want you to say, why are you parking on the line, man? Really, the only thing there is Restful Application Architecture. This is what you're after. So what is it? If you need it, what is it? Well, let's talk about the histories of Restful. This is a short abridged version. There's this guy, Roy Fielding, very smart guy, worked on something called Apache, the HTTP thing, built HTTP protocols, wrote those, wrote the specs for URI. Pretty smart dude, did a lot for us. He wanted to go out and he wanted to figure out what makes the web so successful. Why is it such a successful platform for everybody? And he figured it out. He figured it out it was because of all these reasons, and they're really interesting reasons, right? But we don't need to worry about them so much here. But what he found is over and over again explaining them was difficult. He didn't want to have to explain every single piece every single time. He wanted just, a nice, big, fancy word that would cover everything. So he called it Restful. And when he put that all on a paper and presented it to some other doctors, he himself became a doctor because of it. So here's the thing. Your goal should be to make your app as successful as the web. That's what we're after. Okay? So I call it an atrocity. I call REST APIs an atrocity. And you can say, really? What are you talking about? Let's talk about it. I think the first thing, it's an atrocity because of a forgotten timeline. People think of REST, and they think that's there to power an AJAX site or some JavaScript-powered websites. But they don't remember this timeline. Fielding started REST work in 1996. Microsoft didn't invent XML HTTP request stuff until 1999 for Outlook. The REST dissertation, which made him a doctor and went published, was in 2000. Gmail, the most successful AJAX-based application, and the one that really kicked it all off, didn't even start getting built till 2002, 2 years after REST was invented and defined. Gmail went public, everybody started seeing it, and then it took about a year for someone to come up and call it AJAX, right? And that's when everybody started using it. And here, in the future, when you hear REST, it's going to make you cringe, right? So REST predates AJAX-driven sites. Therefore, REST must not be useful only when building JavaScript-driven websites. I also see it as an atrocity because the web never aimed to be a REST API. When we build a web app and we want it to be successful, we define it by the actions they allow us to perform on the data they expose. Google search is just a big listing of websites would not be very useful. It'd be Yahoo in like 1995, right? It's the ability to search against that data that makes it so useful. Performing actions against data. So we don't build websites or anything that just expose data here. That's not our goal. But so many people, when they say REST API, that's what they want. They want to just build something that spits out some data for everybody to use. There's a name for that type of technology, and it's a data feed. And it can be useful. Many things use data feeds, and they are useful, but they are not RESTful. I find it to be an atrocity because it's a perception thing. When people set out to build an API, they shouldn't be building an API. They should develop an application. An application is something that provides data that can be acted upon, and we like to call these that resources. Resources is data that can be acted upon. You can have a trip to plan or a book to buy, but it's only when an external client consumes those resources that the application can be thought of as an API. So build the application first and then use it as an API. Don't build an API. Just a small perception thing. If you think of it this way and consider an API just as a perspective of your client, you're going to build richer applications that do useful and interesting things, and they'll be RESTful. And that's the problem. What we end up building is an API, when we build a REST API, is an API that generically exposes the data for clients that can do whatever they want, and all it takes is reading some docs to start constructing URLs, and you can treat the API like it's a file, just like the Unix guys always like to do. And we expose everything as JSON, or we expose everything as XML. An API that can be used anywhere. Because of the mindset at the start, you often end up building a big, generic, unoptimizable atrocity. And that's where I get that word from. So maybe REST API isn't really an atrocity, but what happens is people's perceptions and what they go about when they use that concept and what they build often ends up that way. And when you think about something like that, a data feed where it's just spitting out data, is that any different than a database just exposed on 443? And please use HTTPS. That's 98 port 80 there. Consider it this way. A client could just as easily construct an insert statement for a database and send that over as opposed to constructing some HTTP request all by itself and sending that over. There's really no difference there. So why are we building these APIs just to expose them over HTTP and then saying they're REST? Avoid it. Avoid this atrocity and build apps that expose resources that define actions. Be RESTful. It's awesome. So REST API, I've claimed it's an atrocity, but it's still pretty useful because people hear it and they think if it's REST, then it's an easy to consume service, right? That's that first thing that usually pops in everybody's mind. So it's really still a really useful term, unfortunately. So people have been trying to quantify it. Richard Maturity model here. This guy came out and said, hey, you know what? Let's say there's levels of REST. And as you achieve the levels, it makes the API easier and easier. So if I hear that you're a level 2, I know you're this easy. If you're level 3, you're a bit easier. And how this works is that there's the level 0, the swamp epochs. And that basically says it's easy to parse. It's XML or JSON and not HTML, because HTML is kind of a pain to parse. Or some binary format that you got to build a binary reader for. XML, JSON, we like them. JSON's taken over, whatever. The next level is resources, and this makes it easy to identify things by using URLs. This is really useful, and a lot of people, when they think of REST, this is what they think about. Really nice URLs that are easy to change to identify different things, and that they have documentation about what URL to use to get what thing you need. That's pretty good. Level 2 is HTTP verbs, and what this is all about is it's easy to express intent. I want to get this resource. I want to delete this resource. I want to put this resource somewhere. And level 3 at the very top, that makes it easy, but it's the most difficult, is easy to know what actions can be taken and how to execute them. And that is where you get to REST. Now, if you ask Roy Fielding, the guy who invented REST or defined REST, he would say level 0, 1, and 2 are absolutely not REST. He has plenty of blogs where he takes people who claim to have a REST API and says, it ain't RESTful, you're wrong. It's level 3 only. Other people take a softer stance. I'm probably more on the Fielding side, as you can probably guess from me calling everything else an atrocity. But it's very important to get there. But what's happened is so many people have gone, well, I don't want to call it REST level 3 or what that means or what is. We're going to create a new term. We're going to call them hypermedia APIs because they have hypermedia controls. So you'll start hearing that. That's equivalent to a level 3 API as far as I know. And better, I like to think about it because I'm not a big fan, again, of someone building an API. I think of it as a RESTful application. So what are hypermedia controls? Well, If you read the thing, you'll realize that it's kind of confusing, the whole REST dissertation. But roughly they break down to that they identify available state transitions. And a state transition, as I got it defined here, is an action performed by an actor that changes the current state. So over here to over here. This is equivalent to acting upon data. I start at a search form, I execute a search, I get search results. That's a state transition from input to results. So that is the simplest hypermedia control in the entire world, the form, and it's absolutely awesome, and it's been so great, and it probably is one of the secret reasons that the web was so successful back even before Ajax and all those things. Lots of people were using the web. When you submit a form, you're performing a state transition. You're moving from this state to the next state. What's so cool about this is that the browser, the client of this RESTful application, the Google search application, never needed to know you were using Google search. It never needed to know that there was such thing as a search form. It never needed to know what the results were going to be. It's totally reactive to the data that it gets from the resource that it gets from the service. It got a search form resource. It presented it based upon some rules, HTML specifications, CSS specifications, JavaScript specifications, etc. It presented it. It did not need to be custom coded for that. The service is in charge. If they want to add a third button tomorrow, they do it, it shows up. If they want to get rid of I'm feeling lucky, which we all know they recently did, they can do it with no changes to the browser, even though they write the browser too. Links are another awesome hypermedia control. Here we see the search results. Each one of these links, which is a hypermedia control, allows me to transition state. A lot of them allow me to transition state out of the application I'm in. Here I am in Google search. When I click on these, I actually transition over to a whole different application. Yahoo, NBA, Facebook, Twitter, whatever it is. But at the same time, they can use the same control on the Google search to transition to new states within the search app. The next page, page 5, page 6, page 7. We take this for granted so much because we think of HTML and we think how useful that is, and we use it all the time, but we forget how it's implemented, that there's a simple URL behind every one of those controls that the browser can execute, retrieve, and react to. It executes those controls. That's something we shouldn't take for granted when we're building applications, especially when we're building them as APIs. So I like to redefine RESTful architecture. And I like to simplify it a little. I think this is simpler. So I say that an application is RESTful if it provides resources being the combination of data and state transition controls, in a media type that the client understands. So if you can understand HTML and present that UI based upon the HTML response and display those controls and allow the user to invoke those controls, you're a RESTful client. And if you're giving that HTML and giving those controls, you're a RESTful application and RESTful service further. Corollary to that is if your app only provides resources with no controls, which is what a lot of REST APIs do, then it's an app that doesn't do anything interesting. It's an atrocity. So I've said what it is, but let's figure out some reasons why it's actually really good to be RESTful. The biggest thing that I see is it's all about the control of the UX. So you got UI and UX, and UI is the presentation of state, and we often think about this a lot. What's it going to look like? Given this, what's it going to look like, right? But what's more important is how you transition between those states. State transitions, which you use controls to do. This is the heart of any application you build. If you've devved an app, I know you spent more time in arguing about how things should work and how things should move across things than about how they should be presented, because this is what matters. Since it's state transition, it obviously makes sense to offer hypermedia controls to make those state transitions. Shared UX across different things means a consistent client. You can see we got all these different types of clients that we have for our Commerce Hyper platform that we built for our mobile applications. They power our iOS app, Android app. We have these mini trainer apps that allow you to do things and buy specific products. We have our MDOT sites. We have theme sites. We're starting to develop the concept of putting widgets inside of our content, our articles, and different things like that. Those are little mini apps themselves that need to execute and have state transition. Add to cart, move to product page, find more articles, whatever those state transitions are, we want to control that. Even if we built a WinPhone, which we did not, then we would use that. Another great thing about using RESTful application development is its flexibility for change or forgiveness for mistakes, because that's what a lot of change is. Oh, I did it this way, that wasn't right. or making real changes without breaking your clients. And this is super key when building mobile apps because there's something about mobile apps that is very different than web apps in general. In web apps, you're in a browser, you hit F5, you hit refresh, you get the brand new version of that application ignoring cache. But in mobile apps, you cannot force somebody to upgrade. It's their device, they have that app running, it's just like the old desktop days. Most people upgrade. We track that very tightly, and within a week, 90% of people upgrade our apps every time we push a release, and that's really awesome. But they still have other users who are on the older versions who are using them and spending money with us, and we don't want to break them. We want to allow them and gracefully allow them to upgrade. So making changes without breaking your clients is super important. Backwards compatibility. This comes into play with UX changes. So here we have a UX where I'm going from discovery, search, I get to a product that I can add to my cart, I add it to cart, what do I get? I get an ad result. Then I transition to the cart from that, right? Well, maybe somebody decides, hey, you know what, I don't like that ad result. That's not what we wanted. Let's cut that out of the flow. If you don't build a RESTful application, you're going to have to deploy a whole new mobile app to do that, or recode your JavaScript to do that. But if you're building with RESTful architecture, you can just cut that right out. You change the state transition from add to a product that can add when it actually tries to add it, to instead of returning an ad result, return the cart, and the app responds reactively. We do this all the time with websites. Why don't we do it with APIs? Why don't we do it with data feeds? Why don't we do that? And what's great about this is, anybody ever been doing A/B testing lately? Because I'm a big fan of this, right? You do two different ways, you see what works better, you see what converts better, and you pick that one, and you put people in test groups. Switching UX and getting rid of something is the same thing as doing A/B testing. Here we have the B group going to the add to cart result, or the A group going there, and we have the B group going to the cart itself. We can test, track, and follow that, and we don't have to make changes to our clients. We change the UX in every different way that we can. And if you pay close attention to apps, lots of big guys are doing this. Facebook is changing their UIs and their state transitions all the time on their apps. They're running hundreds of experiments at any given time. Amazon, ditto. They're doing this because they have this type of architecture where they can do these things. But I want to give another real example, and this is one that was close to our heart because this happened to us, and it was when I did it and it worked out, I was like, wow, thank God we did RESTful. So URLs need to change sometimes, and it's like hard to say that because everybody builds their URL and they got it perfect and they're like, this is it and it'll be this forever and it won't need to change, right? But here's the thing, URLs, if you ever look at them, there's almost always a database key in them, right? Because you get the URL, the service grabs the key, or the URL, it parses it, grabs that key, and it uses that key to go find the data in the database. Maybe it uses a cookie for ID or whatever, but there's a lot of different ways they'll do it. But generally, there's an ID and a URL. You look at any WordPress post, there's always a little ID value in there to grab stuff, right? So a client, if you build your client such that it constructs URLs that contain these DB keys, then your client is tied to your database architecture. Ever heard of decoupling? Like, it's a good thing, right? But this happens all the time. We have URLs that have these IDs, and we have clients that say, okay, I'm gonna go get product 123, so I'll do product /1234 / and then I'll get that. Well, what if I don't want to index my product by that product ID? So that's one way, but think about another way. Have you guys heard about Sequel Denormalization? It's a good thing for speed, right? Build the data result that your clients actually already want. So we have product pages and they have SKUs. SKUs are flavors, products are like gold standard whey. Originally, when we set this up, we said, okay, we'll have a products table and we'll have a SKUs table. And when you want to get a product, we'll get the product and then we'll make another query to go get all the SKUs and we'll give you the result. Simple architecture, pretty simple, straightforward. But then we went, hey, you know what? This NoSQL stuff's pretty cool. We could put all these SKUs inside the product and just store the product. But we had a problem. We still need to be able to individually index to a SKU. So this is similar. I did an abstract here, but I went with the concrete. Think of an owner, product, pets. If I have an owner, that's how I get an owner /owner ID, and it's pets, I do pet /pet ID. But hey, if I could store the pets with the owner, it could be faster to retrieve the owner because they're already there, one database call. So what do I need to do though, is whenever I want to get an individual pet, I need that owner ID. So if we built this way, in data feed land, in version 1 and 1.1, you'd have something like this, owner ID, pets with their IDs. And a client could easily construct these URLs using the documentation to retrieve these things, right? Very simple, a lot of people have done this, it works pretty well. Data feeds are useful. But in the RESTful land, when you're version 1.0, you see here, we have a self link instead of an ID. And we have links to the pets themselves and not the IDs. So again, I can build a client that, given an owner, can find its pets. It just makes gets to these links. That's very simple too. Not much difficult. In fact, it's even easier than constructing those URLs in the first place. But look what happens when I go to v.1.1, where I reorganize my data for performance reasons. Those two keys are in there. The service provided those. The service changed its entire database structure using different keying to make it so that it could retrieve the data faster for the primary use case, getting the owner, but still make it fast for getting the individual pets too, which still needs to be there. That is really cool. If you built that data feed client and you went to v1.1, version 1 wouldn't work. So what would you do? You have to have an old v1/URL somewhere that only took a pet ID and index that owner's collection with the pet ID as well, and hope there's no conflicts in those things, because now that it's embedded, you don't really need the unique key anymore. So you gotta hope, and you got technical debt, and that's what happens, right? But over here with the RESTful client, there's no problem. You switch those URLs, when it goes and gets that new pet, it doesn't care what's in the URL. It's completely opaque to it. It doesn't matter. So let's talk about how to be RESTful. The first thing you gotta do is content negotiation. You gotta make sure that your client and your service talk the same languages. And we do this as humans all the time. We start off when we go hi and hi. Boom, we know we speak English. We can start communicating. I ask you how to make some money. You give me the get rich quick plan. Click this button. I click that button and I'm rich. All because I knew we could speak English. We talking the same language. We could communicate. HTTP works like this too, only it's really nervous. And when I'm nervous is it blurts everything out right away. It says, hey, I want info and I talk text HTML. And we see these as headers as part of the HTTP request. It's all at once. And there's a bunch of other headers too that are telling it in content negotiation, but that's the most important one. The service comes back and says, I can give you HTML. Here it is. Click this button. That's a hypermedia control right there. That'll give me a state transition that when I click it, I get the monies. So there's different hypermedia resource content types. There's a whole bunch, and we're going to talk about some. HTML, great hypermedia resource content type. Why was the web successful? Because it has an awesome hypermedia content type with really powerful controls like a form and links. Who has not used a form or a link on a website? They're awesome. Don't take them for granted. We have identifiers for those controls. You can see the link is identified by its relationship. It's a profile of this data. And a form is identified by its name. We can write programmatic clients against HTML. It's kind of a pain. It's not so bad. jQuery showed the way with the whole DOM selection with CSS, and now there's JSoup and all these different ways to parse an HTML document rather efficiently and get the data we need. I could easily say, give me the form that has the name, address, save, and follow and get all those little input elements and understand how to submit a shipping address to our system. In fact, this is what our mobile app does. The URLs are still opaque. Again, the browser doesn't need to know how URLs are constructed. It's super important. And controls can have meta information. One of the reasons a form is so important is because of all the meta information it provides. You can say inputs are required, they have max lengths, you can even give them regexes. With HTML5, there's a whole set of meta information you can apply to make that control very easy to understand, to make it self-documenting. Another media format that we're big fans of is HAL plus JSON. And the reason is it's really simple to read. JSON's really easy to parse, right? And it's really easy for people to write. And it's beating HTML or, well, God, I can't remember what the name of XML's parent is that encompasses HTML. But it beats XHTML. It's getting more popular. We're not going XML. Everybody's more going JSON, JSON, JSON for the most part, right? HAL is a way to build a hypermedia content type on top of JSON. And what it does is it puts its links inside the links section. Again, these are opaque URLs. So a client grabs these and it knows how to get itself, it knows how to go to the hiring place, it knows how to look for promotions, it knows how to go get shop buys, it knows its profile, it knows all these things, but it doesn't need to understand the URLs and how to construct them to make these state transitions. So let's talk about a link, because I talked about it a lot. We talked about forms, but links kind of got the raw deal here. We have a person and a dog, and they relate to each other. A person has a pet, and it's a dog. That line right there is a link. If I move from a person to a dog on a website, I'm making a state transition. And I can move back, too. A dog can have a relationship to its person as an owner. This is very simple stuff. If you've ever done enterprise diagrams or or any diagrams or database schema or anything like this. You've done this stuff before with linker tables and foreign keys. Links is just the HTML or the RESTful representation of that relationship, but they're so useful. Links have a lot of pieces to them, though. They have a lot of pieces of metadata that is often optional and ignored. The first thing is that links have a relationship, and this is required. A link must define its relationship between its context, the thing you're on, the page you're on, and its target, the thing that you're going to go to, the thing you're going to retrieve. It's got to have an href because we all use URLs. It can have a name, and this is super important because a person can have multiple pets. But within your domain, you can say, you know what, a person can have one favorite pet. So if you have a person object or a person resource and you want to make a state transition over to its favorite pet, well, how are you going to know that? Well, links allow you to have a secondary thing, a name. So you can have, this link relationship is a pet, but it's also named favorite, and you just follow that. You can have a title as well. That's awesome all the time, especially when you're doing translations on your websites, when you're international. So when you want to manipulate yourself from person to dog, or you want to transition from person to dog, you don't want to have the URL, the thing you click. You want to give something that someone understands. And what do they understand? Human readable text, a title, translated. Say it's my account and I want to go to my savings account. The word savings would be a title, but it could be translated if I'm a different user in a different country. hreflang helps if you have an ability where you could say, hey, you can get this resource, but in different languages. We don't just assume the language. That's our attribute there. So you can choose the link, the hypermedia control that matches the hreflang you require. You also can do type fields. So if a resource is available as different media types, and this could be the case, you can get a dog as HTML, you get it as PDF, you get a JPEG of it, however you want to get it. Each link could have a different type there. So when the client is trying to make a selection of where it wants to go, it can use that type information to make the best choice. And then what's really cool about links is they can be extended. So Hal does this. Hal takes a link and does one additional thing. And it turns out that a lot of times you want to have user input, right? You want to change the state transitions results by something. So what you can do is you can actually do a templated link in HAL. And this is one of the reasons why we like it so much as a media type format. Because it's same as a link. It looks almost like a link. All it does is add this little templated equals true. And then it uses this RFC 6570 that you can see is the squiggly brace replacement algorithm, in which you can define all these parameters that can be bounded to user input to help change that transition. It's kind of like a form. It's not quite as powerful. There's not a lot of validation built into the response based upon the param names or anything like that. RFC 6570 does define a little bit of stuff. You can do sizes and things like that on the input size. But it's really, really useful. If you just start using it, you'll be amazed at how many use cases it covers. Another thing that we love about HAL is that because the way to identify links is their relationship, it actually indexes the links by their relationship name. So in the underscore links, each key in that JSON is the relationship name. So that is some rel. That's the relationship name. That makes it really easy when you just parse it as JSON to grab things out. A lot of different things don't do that. They give you an array of links, and then you got to walk through every single one and then see, hey, is your rel this one I'm looking for? No, go to the next one, go to the next one, go to the next one. It's not going to kill your CPU time. It's not going to kill your app, but it sure makes it a lot nicer when you're using it. So there's a lot of hypermedia types. Here's a whole bunch. And we don't talk about any of them really specifically, but each one of them has their own controls. And they're different. Notice they're known to are the same set. They all intersect with each other, and this is not a complete list by any means. And when you get a hypermedia type, whether it be text HTML or HAL plus JSON or Mason or Siren or Collection or Atom, any of these things, all those things do is tell you how they implement those controls. So you can see here, HAL, the links are an underscore links. And the templated link is an underscore links with templated true. But over in Atom, a link is a link tag. It changes different types. The media type identifies how to identify the data and the controls. That's what it does. So how do you choose the right content type or media type when you're building your application? HAL doesn't have forms. HTML doesn't have template links. I both said they're very useful and you can use them a lot. Well, neither one's great. They all have different controls. There's not a perfect all-encompassing media type. It's okay to use different content types for different resources in your application. That's RESTful. It is okay. There's content negotiation every day. For any resource, choose the content type that has the controls you need to represent the resource best. What state transitions do you need? What level of control do you want in that? Use that control. But make sure it's always RESTful. There's a whole scale of things, right? JSON is very little control at all. Very much a data structure. Where if you've been looking at the Facebook React stuff where JavaScript's passing off to the client and executing, that's all control. Very little data. It's almost all control. Pick where it makes sense. Do what you got to do. Content negotiation will help you here, and I want to show you something. It's something we've been working on recently because we really think this is important. Here I got my Bodybuilding.com page. I go to it, a browser. What does a browser say? I accept text HTML. So what does it get back? Text HTML. But I've got this nice little plugin here that allows me to override that accept header. And I'm going to switch it. I'm going to say, hey, you know what? Give me back application helpless JSON at a quality level of 1 and text HTML. Oh, man, it's hiding. At a quality level of a half. And if you know about content type header, accept header, what that means is I prefer helpless JSON. I want that. So if I turn that on, and I go over here, and I refresh, same URL, I get the helpless JSON representation of that product. And we are doing this almost everywhere on our site. We're making it so that you can get different representations of our resources because different clients want them different ways. Further, some features are only available in certain content types. So a client must say, hey, I want it that way or this way, but the client reacts to it. So what's funny is when we started this, I was like, hey, I'm going to build a mobile app, and then it turned out I didn't get to build one, and I was really disappointed by that. But we have a really good team of mobile developers at Bodybuilding. It was awesome to work with them. I was really worried they weren't going to buy into this RESTful thing, and the first thing that a guy said to me when we had our first meeting about it, he said, hey, sounds like you're doing all the hard work, and I love that. But I had a bad approach. Originally, I was like, man, if we build a RESTful service, we have a RESTful structure, we're good. It's done. That's not true. I forgot about how great the web browser is. I forgot about its principles. You need to build RESTful clients to take advantage of RESTful services. You can't just do one side. And it's hard to build RESTful clients. It's not as easy as it sounds. It's much easier to put together something that just grabs it, a URL, and treats it like a file. So what we do is we often look, when we're building and we're developing things and we're thinking about things, we think of our mobile apps as a browser. We go, what would a browser do? If you're building an Ajax app, an Angular, iOS, Android, whatever it is, do that. What does a browser do? I want to be more like a browser. Browsers are reactive, so you must be reactive. You never assume the result of the next state transition. Request the transition and react to the response. Think about this. I'm on Facebook, or somebody links me to Facebook, and I click on it, and it's a protected resource, and I get a login prompt, right? Does my browser crash because it didn't get the post that it expected to get? No, it reacts to it. It says, here's the HTML login form, go do your thing. The service actually makes it so that state transition of submitting that login form takes you to your designated resource, I hope. I hate those sites that don't do that. But that is really cool. It reacts. But how many times have you built a client that immediately assumes what its next thing is? And if it doesn't, then it's an exception, and it gets thrown to an exception handler. It doesn't expect anything. It expects something, and if it doesn't get that, something's wrong. That ain't good. That ain't what you want to do. We have products that go discontinued all the time. Do we want to give them a discontinued resource? Sometimes we do. Other times we want to send you to the new product. Other times we want to send you to the category of that product. We don't want our mobile app to crash because it thought it was going to get a product, and then it got a category instead on the response because the A/B test said, hey, let's do that. We got to be reactive. Continuing being reactive, never require a previous state to achieve a subsequent state. This is key. This happens all the time. You build something that searches, and because you follow a product link on a search result, you assume you're going to get a product. It's the same problem, but more finite and specific. Think about Google search. Does Google search care that you got to the search result because you submitted the search form? It likes to know you put some information in that form, maybe as a hidden input control, so that the search result app can actually tailor the thing, like what the query was you had, but it doesn't require it. It's not necessary. It doesn't need it. It doesn't care about the previous state. We see this all the time in real-world problems. Login prompts I talked about, errors. Something went wrong. Clients should be able to react to that error. I kind of glossed over this, but I should have pointed this out actually. Over here, notice these ones down here, Mason has the concept of an error control, and so does Siren, wherever that is. Yeah, so does collection plus JSON. Errors are so tough to deal with, a lot of people have built hypermedia controls just to handle them. But if you're a reactive client, you don't need that hypermedia control. You just react to the state that you're given. And if it's an error message, it's an error message. UX changes, we talked about that, switching the thing. If I built a client that demanded I get an add to cart result or expected that when I add to cart and then thought it was an exception when it didn't happen, we couldn't change the UX on them. We couldn't A/B test them on the fly. Redirects, talked about this, to your project. Outages, if site goes down, well, we have Akamai in front of it and all these different things. We serve HAL JSON to our client, our mobile app. If we're down, Akamai sends a JSON response to our mobile app that says, hey, we're currently down. Push notifications is super important. When you get a push notification, there is no previous state. You just got a URL to go somewhere. You got to target a deep link in your app. We can't have a previous state. Again, A/B testing. So there's some techniques to help build RESTful reactive clients. This is one of the things we learned as we went along. Probably the biggest gain of knowledge we got was doing this. When building a client, think of it as a very fancy browser that allows for very sophisticated, interactive UIs, an Uber browser, meaning instead of just using HTML controls, use native controls in the app. Use the view that makes sense for your app that works, but think of it as a browser. A browser builds native OS controls for buttons and for drop-downs and things like that. Remember what back in IE6 when the select thing was always over everything else no matter its Z-index? That was because it used the native comp control. Maybe I was the only one that dealt with that. If your client app receives a resource it doesn't understand how to build a UI for, it might make sense just to open it up in a web browser. Hey, I asked for HAL, secondary HTML. The service said, all I got is HTML. You know what? It's okay for an app to display this in a browser. In fact, we're seeing this more and more. If you look at Facebook now with its Insta posting or whatever it's called, Insta site, that's what it's doing. It's not taking you to the real browser, it's bringing you to an in-app browser. But if it can't get the native resource or native JSON or React Native or whatever it wants, and it gets HTML, it shows you that instead. Avoid putting decisions in your client app. Whew, can't do this enough. Decisions or state transitions. Make those part of your resource. A trick we found, have the client app identify itself to your service with a name and a semver, semantic version. This allows the service to provide compatible resources for a given version. It's a better alternative to URLs that have v2 and v3 in the thing. Those are really tough to maintain in my experience. It's so much easier to have an app that says, hey, you know what? This is app 1.1. I like 2.2, but this is 1.1. I know that they can't handle links that look like this. I still want to support them because we're still making $1 million a year on this version of the app. I'll tweak my response a little bit and make it match up for them. I'll use the new database and the new data. I'll do a little extra work to keep that backwards compatibility. People are worried about that. I say put it in the user agent header and everybody will probably gripe and go, user agent sniffing is the worst, right? Well, if your API requires it and it doesn't work if you don't have it, you can guarantee that everybody's going to do it. And it doesn't have to be the user agent header. It's a good one. The tough problem is JavaScript clients can't actually change that when they make AJAX requests, so maybe use a different custom header. We use BBApp. But on top of that, one of the great things about having the client identify its version is that when you do that, you can say, hey, you know what? As we're supporting this older version, there's diminished returns here. So at some point, you want to turn off that old version. So what you do is in your very first version of your app, you identify a resource type that says, hey, you know what? You need to upgrade the app. And the service can reply with this, and the app will know it needs to upgrade to continue. It'll display a screen. What we do is we actually return what's called a web page blocking resource, we called it. Roughly, we can put anything we want in there, and that works for service outages or alert notifications or whatever it is. But if we return that, our app displays that as a web page. Whatever the content we give it as HTML, we actually give it a URL to a web page to display, so it's kind of double linked. But we give them that, and that may say, hey, you need to go update, and it's got a deep link to the App Store to go update. That's how we force upgrade people if we need to. So a really hard part about building RESTful clients is that whole I can't know what my previous state was. I just did a product search. I followed a product link. It's much easier to think, hey, build up the type structure and say I need a product. How do you know what you get when you hit the other side? How do you be reactive? How do you identify what you got? It's not easy. And I know two answers that are out there other than scanning the data and like doing profiling on the data and say, oh, because it has this field or this field, this field, we're not going to do that. So the one way to do it is using content types itself. So when the service returns, it tells a content type, and that information is in there. And how we do this in the large is this thing called vendor content types, vendor-specific content types. You put this VND dot in front of it, and then you put what it is, and then you plus to whatever it kind of is more generically. So you can see here, I've got something that's HAL and JSON, but it's also a product. I can treat it like a product. I'll build a product UI. And somewhere, there's documentation somewhere that defines what VND.product plus HAL plus JSON is, what fields it has, what controls it has, so that clients can build their entire interaction and UIs built on top of that, know what fields are guaranteed to be there, what could be empty, what could be null, et cetera, et cetera. But I'm not a big fan of this, first and foremost, because of namespace collisions. I don't want to have my identifier ever be used by anybody else, because I might want to build an app that uses both. If I build a product service for bodybuilding and bodybuilding buys another company and they have their own product service, I hope that my content type is different than their content type, but it's not going to be. It's going to be product plus HAL plus JSON probably. So you get collisions. It's not dereferenceable. We're in the web, we use URLs everywhere, and yet this isn't a URL. I can't take this and get documentation for it or do something with it. And the other thing is, this is a more advanced thing, but I really like the concept of mixing in pieces of data so I can have a single response be multiple resources. For example, I can have a product be both a product and an error message at the same time. You can't do that with these vendor types elegantly. It's very difficult. You've got to come up with a whole different scheme of content types. Hard. So we went looking for a better solution, and there is one. It's called profile links. And the idea is your content type already defines how to identify links by their relationship. So what they did is they standardized a link relationship called profile. And what it is that every href of that profile is a URI that identifies the profile of the resource you have. So if I see this, I know that I have a Bodybuilding.com product. I love this because it's URI, so it avoids collisions, right? I put my host name in there. It's great. You talk about microservices and having things in different domains. When we have different apps provide different things, we use different domains for the profiles. So a search product could be different than a catalog product, could be different than a review product. They're dereferenceable to documentation. Now, this doesn't work for our stuff, so I'm really sad about that. One day it will. But if you click those profile links and follow them, you get human-readable documentation for that resource, telling you what fields are there, what can be null, what's not. Further, because it's a URL, say you come up with some machine-level documentation so you can build automatic processing. When you follow that URL, you say, hey, I accept machine language content type, and our service returns the machine language definition of that resource so that the machine can do the job. There's 1,000 different machine languages. We do content negotiation even on the documentation. That's pretty cool. Now, we don't do that, but we could. Finally, traits is really simple. You have a lot of profile links. Recently, we just added this whole new concept to bodybuilding about verified products. We take them to the lab, we test them, we make sure that they have all the things that the ingredient label says they have. Really cool thing. A product is either verified or it's not. Well, we could do that with a Boolean. We could say, hey, it's verified equals true, right, on a field, on a resource, and just do it that way. But it turns out that as things are going to go on, we're going to start giving you information about why it was verified, what test results are. Maybe. Who knows what it's going to do, but it can grow and have more controls for itself, have more data for itself. So by making it its own profile, we mix in that secondary concept on top of the first one of a product and allow us to expand on that and have our clients react to that directly. Further, if a client was developed not knowing what a verified product is, it's an old version because we added verified in 1.1, it doesn't hurt. It doesn't hurt that there's an extra profile, it just ignores it. All it does is says, hey, are you a product? Are you a SKU? Are you a category? It doesn't say, are you not this thing I don't understand? That'd be silly. So a proposed design for reactive clients. Start with the URL. And if you read the REST documentation, this is the uniform interface constraint, if you've ever read it. From a URL, turn it into a resource with the resource factory. Get a resource from that URL. Understand the content type, get all the controls, get the data, pass that off to a view factory. That view can use the profile or whatever classification information to determine what view is best, and then it can use that view to display to the user. And if you like it functional, which I do, go URL to a resource to a view. Let's go further. Make it RESTful by using controls. Take a control and go to a URL by taking user input, a form, a parameterized link, whatever it is, to a resource, to a view. Users use views to view a resource's data and invoke a resource's control. That's your architecture right there with a RESTful application. That's how to build a RESTful client. It's not super easy, but if you do it, you'll gain so many benefits. So I said it's great. I said how to do it, but why aren't there a lot of them out there, right? Because it's not the most popular thing. Data feeds, there's a billion of them. Why is everybody doing that? Well, you forgot about the web. The whole web is RESTful. All of it, Google, Facebook, all your favorite apps are super RESTful because they're HTML. HTML is RESTful, they use HTTP. They're almost forced to be RESTful for the most part. You've been on a few websites, the ones where you can't like cut the link and paste it to your friend, they get to a totally different page and you hate that. They're not RESTful, but most of them are. So why are there so few RESTful APIs? And this is what I think it was, because this is what it was for us. It's knowledge, it's service tooling on the service side, and it's client tooling on the client side. So now that you got this presentation, I hope this helps. There's other ones out there. If you message me, I'll give you links. I'll dump so much information on you that you'll cry. Tooling, we've got a solution, and we call it HyperFit. We're going to talk about it in another presentation. It's really cool. I like it a lot. On the service side, it's getting better. There's Spring HeyOS. There's REST Easy. These things do good things. But we use them. We're using them right now. There's limitations. There's things they don't do for us. So we're trying new things. We're hoping to be set the pace here in this space and maybe come up with some better ways to build RESTful services, or at least contribute back to those projects that have already been started that are really good already, but just not quite the vision that we have for these things. So I ask you to keep up to date with us on Twitter, bbcominj, that's me on Twitter. We have a tech blog. We're going to start really posting a lot of really interesting things on there. We got a couple open source projects that are going to launch. I know we have a lot of backlog. We've been working on this. We're up on GitHub now. There's, I think our first project's up there, although maybe not launched or announced, but it's a really good project. I will use it. And then you can actually browse around our API. It's RESTful, so because it has all the links there, it's actually self-documenting. So if you go there, you should be able to figure out how to build an entire supplement e-commerce thing in about an hour. Don't do that, please. All right, any questions? Uh-oh.
No questions? Oh, here we go.
Hey, this was a great presentation. I really enjoyed this. My question, though, is it seems like some of the greatest benefits of REST are already present in HTTP, HTML, and the browser. Why are we reinventing that if that's the way to go?
Really good question. I didn't plant that one, by the way. So ask Roy Fielding, and he'll tell you to use HTML. That's what he says all the time. Use HTML. Why are you using JSON? My experience, devs like JSON. Like I said, it's really easy to parse and read. It's human. HTML is awesome. HTML has a lot of baggage regarding its layout structure, and they've tried really hard to move that layout structure more to CSS. So like, there's this whole concept and this dream that you could have HTML just be like your semantic data structure, and they do this in micro formats, right? And then you can use CSS to do all your styling. But every single HTML developer ever has given up at some point on CSS and switched some tags around and done some things to make it lay out the way they need to on IE 6 or 7 or whatever. So I think a lot of people go, HTML, it's a layout language. That's their first initial thing. I got some good devs on my team, and they've asked this question a bunch of times. And in fact, in certain parts of our API, we gave up on how it didn't work. We use HTML, XHTML, and HTML5 to return resources because we need the richness of form controls. When you're in the checkout process and you're entering shipping address information, based upon who you are and what information we have and what country you're in and whoever decided to do whatever that day and make what field input it is, the app has to react to the fields that we require and what fields are required and what the regex looks like. International numbers are different than local numbers and stuff like that. We could have built our own specification format for that in HAL. There's actually one that was started called Halo. Siren kind of has that concept. Mason kind of has that concept. But none of them were really good. You know what's great? HTML. The HTML we were using on the full site. So I took that, cut and pasted, and started serving that back. And it worked. So I don't know why.
Do you guys have any kind of, golden, this is where we want to be, where all of your data suddenly becomes flexible and your REST determines, front end, back end, application transitions, all of that. What's kind of the best thing there? Or do you see it as a pragmatic, well, we need to ship things, and so we build applications that focus on shipping?
So my manager's not here, so we always do what's right. But if he was here, I would say we need to ship stuff. No, so what you're hitting on, I think, is that service tooling I talked about. And I said there's not a lot of great options there. And the biggest complaint I have with all the options that I've seen is that they all start with the idea that you have a full site, you have HTML, or you have a database, and you have a flow, and now you want to expose it as JSON, as XML, as a hyper resource. They all start with that. And I don't like that, because if you actually read one of Fielding's opinions on the whole thing about how he describes resources, and it's even in the spec, he says a resource is not the thing you get from the response. It's not the JSON or the HAL or the XML or the Atom or the Sart, whatever. It's not that. That's a representation of the resource. The resource is an abstract concept that only exists on the server. So what happens is you need to start building the resources on the server. And this ties in a lot to like domain-driven design, because a lot of these things are similar. Like a resource is kind of like an entity in domain-driven design. It has its actions. If anybody's familiar with that, if not, I'll stop talking that way. But it's very similar in that the resource has the actions, lets you do the business logic, right? So what happens is people start with the full site, then they build an API, because the tooling kind of pushes you that way. What we've been really trying to look at is making it such that your service builds a resource, and then only through content negotiation and content serialization at the end does it output it as the representation that it needs, be that HTML or JSON or whatever it is. So build it once with all the controls and all the logics in more of an abstract sense. It's hard because you can't just say, I'm going to add a form to this resource, because if you want it as HAL, there's no equivalent to a form. What there is templated parameters. And so can you compile that down to a templated parameter and how you do that? So we've been playing with that and working on that. And that's kind of what I was saying we've been working on. The idea being that we would have a single application. So if we had search be an application and you execute a search, it generates a search result resource, and then it's only through the serialization process that it generates HTML that displays a search result for a browser, or it generates JSON, HAL plus JSON representation that represents a search result for a mobile client. Does that help? Or
Okay. What's you guys' current approach on decoupling, or do you attempt to decouple application state transitions from the server-side data representation, or are you guys, are you bought into, coupling your representational state to the transitions that are available from that representational state?
I'm not totally familiar with that terminology.
Sure.
Are you talking about there's controls that aren't there because of the state of the resource?
Sure.
Or?
So, for example, if you were to just pull up one of the Bodybuilding.com, index pages, and that was undergoing an A/B test, right? Where the transitions were changing based on which segment you're in. Do you guys simply say, okay, we change the transitional states that are available from that, and you have a single authoritative spot where the entire page gets pulled, it defines all of your transitions, or do you try to decouple your transitional aspects of your application from the data model, I guess?
Okay, so we use Optimizely for some of our A/B testing, and that's like a UI-only kind of framework.
Sure.
So in that case, we don't get to do what I'd like to do, We get to return the resource as it is, and then use Optimizely on the client to change some URLs or change some buttons around, right? So
Okay.
they would be decoupled by there. But more what I'm interested in, and this is what we're working on, is having it such that when that resource is created on the service side, the controls that are added are based upon what segment, what A/B test group you're in, whatever it is. So I talked about the UX where, hey, we're going to go to the add to cart result, or we're going to go straight to the cart, right? When we add the add to cart, the BB add to cart link relationship to add something to your cart, right? When the actual control that is behind that relationship, if you're in the A group, will be different than the control that's in your B group. Now, if they take different parameters, it gets messier. Again, that's why we don't have an answer yet, because we run into these problems. I'll tell you one of the really cool ones that I often bring up. Everybody in the front row here's heard me say it 1,000 times. So we're moving to a eventually consistent system. So what you see on the product page may not be like, let's say, the price that it is in the cart, right? Before, without Hypermedia, right, they had to be consistent all the time, and that was impossible because people had cached pages, right? It never really worked, but it kind of worked. Once you go eventually consistent and they can have that divergence on price, you have to be able to like help the user. Maybe you can do it blindly, but help the user be better. So when I add to cart, right, if I give them an add to cart link and they execute it and they move over to the cart page and it just says, yeah, it added to your cart and the price is now $5. But what we'd like to do is give them a message like, yeah, you picked $4 and now it's $5. So in that B group, when we try this new thing, what we do is in the URL that's the add to cart, we put in what the price was and the time that we figured out that price, and we sign it, HMAC it. And then when it gets added over to the cart app, which is a totally different microservice, right? It gets that information, and because it's been signed, it trusts that information, and it can do a lot of things. It can say, hey, you know what? You added it at $4. It's moved up to $5. I'm sorry. Everybody's seen that on Amazon. We all cheer when it went down in price, and we go, we'll buy it tomorrow when it goes up in price, right? And then it always goes up, and you never get what you want. But we could go further. We could go, hey, you know what? Because the time was within this window and because you're this valued customer, we'll just honor the $4. Why not give it to you for that time? But we could never do that if the client was constructing its own URLs, right? So you can shove state information inside URLs, and it's really useful for A/B testing. It's only when the user input changes that it gets tougher. And like Facebook solves that with their React stuff because it's all control. It's like, here's the control, and here's how to interpret user input, and here's how it is. HAL is more declarative programming. It's more stateful. It doesn't have so much control. It's not on the far right of that scale, right?
You mentioned that doing the RESTful approach is harder on both the server and the client side, even though the front-end guy said, oh, you're doing all the heavy lifting. As the architect pushing this, how did you sell it? What was the big win you proposed to get people to take this on?
I don't know. Ryan, when did you finally say it was okay?
You said you were going to write the client. That's probably when they were cool.
It was hard. One thing is that there's a lot of big industry players who don't do it. Netflix doesn't do it. They're very successful without it. Why is that? Well, I think one of the reasons is that their clients are very distinct devices where everybody goes and builds their own personal API for their device. They don't require it. We wanted that shared UX experience, right? A lot of the sell was probably mostly the initial thing that I probably didn't touch on enough when I started off, which was, because I thought you guys were going to laugh a lot more that I only got a phone a day before I got hired. I thought that was cool. Anyways, that they wanted that shared, consistent experience. How are we going to get that shared, consistent experience? Because if we just go build an API that serves data, the business can't change that data the way they can change that data on the full site. They can change the experience, and we do that. So that was a big, big selling point. The other thing was just like, hey, let's think about UX. Let's not think about data. That was something that I think it was lucky. My manager, some of the people higher up than me, had already tried that. They fell in a very common trap with data feeds, and it's in Java and .NET. You'll build like this entities class, or entities classes on one side, and you'll populate them and then serialize them as JSON. And then you'll go, you know what? It's the same thing on the other side. So you take that same jar and you'll share it on the other side. And it'll be the same one on both sides. And that always happens with data feeds. I see it all the time. And they had already done that, and it didn't work for them because they made a change here, and it didn't change over there, and it caused problems. It was a big issue. So they had tried the data feed thing, and they were like, we need something different. This was attempt 2. It wasn't like the first time bodybuilding wanted to build a mobile app was in 2013, right?
So would you say that the forced decoupling was a win from this?
Yeah, that was a huge win. We see it all the time right now. We're changing stuff. We're deploying stuff. Like I said, in the middle of the project, we completely restructured the database. You can't do that if you're building your own URLs. Another thing is that middle of the project, we decided, hey, you know what? We want cart to be on its own domain. Because we're going to take all the www SEO-friendly read-only stuff and put it in the cloud, and we're going to put cart in our data center where it actually makes change of state. I want different domains. I want different DNS routing for that. We changed that. It was, I don't know, 50,000 lines of code. We got some good programmers who did it, and the client didn't change one iota.
So you kind of talked about, just there at the end in that question, about sharing an entity with your, your maybe front-end client, right? Where do you draw the line between maybe like a domain model object and like the UX state? Do you combine those? Are those separate? How do you kind of define that boundary?
So when you looked at this structure I propose, somewhere. Here, this one. Control to URL, or this one, the view factory, resource factory URL. Have you ever heard of Mvvm? Okay, Mvvm is the idea that you bind this view model that has data and controls to your view. A resource is data and controls. So a lot of the time, I like Mvvm, I've always liked it. I say, hey, you know what? The resource is the view model, and it has all the controls. And the view is just a representation of that resource visually for the user to use.
So I was that last line there, the control to URL to user input to resource. So, if you have your server or your service returning the different types of controls, right, and then the client, your web or your app, right, is rendering a native version of that or an HTML version of that. Is that kind of how? So you guys are defining the UX states really on the service level?
Oh, yes.
Okay.
I mean, that's the controls, the transitions.
Yeah.
So it's like HTML. Like when you want to build a form, you do it on the service, right? I mean, you can do it in your client dynamically, but your resource is the HTML doc. When you build a forum, you're often like manipulating the HTML doc, your view model, to build that control and its behaviors, hidden input elements, required fields, etc.
So have you guys kind of found a way to think about maybe your domain model, right, in more of a UX kind of process or thought process? Or how do you kind of wrap that up, right?
Yeah, that's a great question. Okay, so our structure on the service side, we do CQRS, which is command query responsibility separation, right? We got read models and we got write models. We replicate across. We transform the entity into what it needs to be, as close as it needs to be that resource in the read model for almost anything we can that we can do a read model with. But there's still problems on the right side. Like a cart cannot be used by a read model. It has to be 0 SLA from the write model. So either way, it doesn't matter. You pull the data out, but sometimes it's really close to that resource, and sometimes it's far away from that resource, right? So, it's domain-driven design. And microservices, you got your cart app that does it one way, and you got your catalog app that does it another way off that Mongo read model that we have, right? The Mongo one is really simple. It pulls it out. That thing has some URLs. It has some resource targets. It's got different levels of hypermedia controls in the Mongo database. And that's, at the time, because of the decision, what we were thinking at the time, what we liked, what we tried, we're changing that constantly. I don't have great guidance on all that. Putting URLs in the Mongo is really cool. Putting URLs in the Mongo can be really dangerous. Putting URLs in the Mongo sucks. So that's simpler. We take it out of there. We started Spring Helios's pattern, which is get data, DTO. We call them entities because they actually have some business logic on them, like helper methods and stuff that deal with time-based stuff. And then use an assembler to turn that into a resource. And a lot of the controls are added in the assembler. I have another talk that goes over how we did all that that I want to do. On the other side, it's messier because it's a write model. It's an Oracle database. You got to pull a lot of pieces together. We're built on top of a very special ORM technology that is proprietary, not to bodybuilding, but to Oracle that we bought. It does a lot of the logic for us, so we can't do a lot of control there. So case by case, but a perfect read model is a flat JSON file that has the result, right? So if you go in CQRS, every URL request for every user, for every store, for every language, there would be a file in the system that already has the answer to that for every time index in the world. That's like the holistic thing, right? It's 1 o'clock on Saturday the 5th, right? Grab this file from this directory. That'd be great. You can't get there. You got to manipulate the data somewhat. But we try to make that as small as possible. I've dreamed of, hey, let's have tooling that tells us which ones are close and which ones are far, either through execution time, number of operations performed on the entity, things like that. But what we really strive for is only one query to the Mongo database. We get one query and then we're done. Anything we need to eager load in a UI or anything like that and return so that it's part of the initial display has to be in the database. We do the one call and turn it back. We don't do any other asynchronous calls currently or anything like that. We try to make it super fast, and then everything's deferred loaded on the client that can be, that should be, that doesn't need to be eager loaded.
Any more questions? Yeah?
There's another presentation after this, so maybe we can get it offline.
This one's short. On a scale of 1 to 10, how much do you like Martin Fowler?
Oh.
Why do people have such opinions about that guy? He just had a whole post where he just had a whole post about do the monolith first that I really liked. So maybe I disagree with him. I don't think about him like I don't go Martin Fowler's right or wrong, but I think we agree on a lot of things. And other things I go, what are you talking about? Good question. Thanks, everyone. I appreciate it.